Hey, welcome back to Unit 15. We're talking about surface area of prisms and cylinders. Now, there's a couple words we got to learn. Number one, we got to learn what surface area is. Okay, that's pretty straightforward. And a prism, what's a prism? It's not a place you go when you're in trouble. No, this is a prism here. A rectangular prism is a three-dimensional figure with two identical rectangles that are connected by other rectangles. Now, the best part about prisms is that everybody kind of sees them differently. So let's talk about this one right here. I mean, it's a box. Really, it's a box. But what's important is that we have right angles, right? This goes like this. The box isn't leaning one way or another. And according to the definition, a three-dimensional figure with two identical rectangles. So let's pretend in this first prism here that here is a rectangle, the top of it, and then we know, of course, the bottom of it would have what we would say is a congruent rectangle as well. It would be the same size as the one on the top. Now, if you notice, they are connected to each other by rectangles. This is a rectangle. We'll call that rectangle number 1. This is rectangle number 2. Opposite rectangle 1 would be rectangle 3. That'd be on the back. And then we'd have another rectangle on this side over here. That would be rectangle 4. And then if you counted the top and the bottom, that would be 5, 6. So really, when you take 6 rectangles, opposite rectangles are congruent to each other, and you make a box. That's what a prism is. Okay. And today we're going to be talking about how to calculate the surface area. So the problem that most teachers would use is, hey, we're going to wrap up a gift for Christmas or birthday or something. And so how much paper do we need, or how much paint would we need to cover it? That is a typical surface area question because it involves calculating the area on every face of the prism. Now, some things we have to learn what some of these words are. So let's put some of these words. The two most important words that we're going to start with are face and edge. And when we talk about a prism, this flat rectangle right here, we could call that a face. But we could also call this one right here. And of course, on this side here, we're going to go through everything. Let's go like this. Okay, these are all different faces of the prism. Now, if we talk about an edge, we're talking about the line that connects two faces. All right, so you think of it as, what's the edge? It's like the edge of a table. Same. I mean, it's same. We're using the same language here. This point right here, where 3 edges come together, that is called a vertex, but we will not be needing that. Today, we're just going to figure out how to calculate, as we said, the surface area. So it's the area around the outside of this prism. Now, there's an ugly formula. This is ugly. Haven't seen anything this ugly since I looked in the mirror this morning. Look at how long, what do we got? 2 LWs, 2 HLs, 2 HWs. What do you think all of those words or all those variables stand for? So let's try to figure it out a little bit. What we have to do when we have a prism is we have to figure out what a length is. Okay, so we'll call this side right here, this long distance here, we'll call that the length. And then we have a width, just like with a regular rectangle, and then we also have a height. So let's label this as width, and let's label this as height. And I'll show you how this formula works, but I think it's a little easier just to not use a formula, but we're going to start with a formula. What you need to do to find the surface area, as we've said, is calculate the area of each rectangle around the whole box here. So the first part says we need to find 2 times the length times the width. Now, the length, this distance from here to here is the length, and we said that this distance was the width. So when I do length times width, it will find and it'll calculate the area of this rectangle, the top part of this prism. And that's nice. But we also know that the top rectangle is congruent or the same size as the bottom of it, which would be under here. We can't see it because it's on the bottom of it, but it's the same size as the top. So that's the reason we have 2 of those. We have one on the top and one on the bottom, and we do length times width. That would be the red rectangle. Now, what about the height times the length? Well, this is the length right here, as we said previously, and the height would be this distance here. So that would calculate the area of the front face of the prism. And of course, just like the top has the the front would have the back of it, it's the same size rectangle. So when we calculate height times length, that is the formula for the area of this rectangle here. And then we do times 2, so we get the one on the back as well. That is top, bottom, front, and back. And then we have one more, which is the height times the width. And when we look at it, the height is right here. The width goes back. So that will calculate the area of this face here. But like the other rectangles, the opposite face would have the same dimensions and therefore have the same area. So we need 2 height times width. So if you're a formula person, you really could just say, okay, well, the length equals this number and the height equals that number, and we can plug it all in, and then it's like beep, boop, boop in the calculator, and then come out with an answer. But I'm going to be honest, the way that I like to do these is I like to simply just find the areas of the 6 faces. So let's do it that way. Method 1, find the areas of the 6 faces. So I will redraw this to the best of my ability. All right, so we're done drawing this down here. It looks very similar. I am really good at replicating. And our first method is going to be to just add the areas of the 6 faces. Now, before we begin, off here to the side, we're going to look at this prism here, and we notice that the side lengths are measured in inches. That's the unit, inches. Now, when we calculate the area, let's do that. Let's start and calculate the area of one of these rectangles. We'll say this rectangle on top. I'll shade it reddish. Okay, what is the area of that red rectangle? Maybe I'll put it over here. So the area of the rectangle, the red rectangle, would be this distance, which is the length. We'll call that 6 times whatever this distance here would be, and that would be 5. So 6 times 5 is 30, and I'd like to talk about the units for a second. Now it's 6 inches. An inch measures distance. We know that. It's like from here to here, depending on how big your screen is right now. But let's pretend an inch starts here and goes to here. That is a linear distance. It goes one dimension, one direction here. It's like a tape measure. You just roll it out. Now what we are measuring is the area. It's how much space fills this plane right here on top. It's how much paint we would need, how much carpet. Okay, you can't measure that with a single distance because you need 2 directions here. So the unit that we get is actually going to be an inch times an inch, which creates this. If we go an inch this way and we go an inch this way, we get this little tile. And the question is, how many little tiles that are an inch by an inch can we fit on top of this? And one of those little tiles is called a square inch, which we can write like this, an inch with a 2 raised up as an exponent, or sometimes people will abbreviate square inches. If they use an exponent, which I'll be honest, I like to use the exponent. It doesn't mean that we square the number 30. That's not what it means. It means that we're talking about these little tiles in terms of area. It's a square inch. Now, I've already done part of this problem. I've calculated the area of this rectangle on the top. Now, we know there's a rectangle on the bottom. That rectangle on the bottom is congruent to the rectangle on the top. They would be the same. If these were bricks and I took the top of one brick and put it on the bottom of another, or vice versa, they would match up completely. So we know that we not only have one rectangle that has a surface or an area of 30 square inches. Whew, that was hard to get that out. We're going to have 2 rectangles. So we'll have a total from the red of 60 square inches. That'll be the area from the top and the bottom. Now, we have to do the front of it, of course. We'll just kind of mark that green here. And the front will be congruent with the back, right? They're going to be the same. So the area of the green rectangle here, it's the same method. We're going to go 6 times, what's this? That is 4. It's the height. So the area of the green would be 6 times 4, which equals 24 square inches. But again, we have 2 of them, so we'll double it and get 48 square inches. That's the area from the green rectangles. And then lastly, this rectangle right here that we will shade in some blue. Remember, that's the same. This rectangle on the right is the same as the rectangle over here that would be on the left if we were to shade it in. They would be the same. So we'll say over here that the area of the blue rectangle would equal, what is this, the dimensions? 5 times 4. So notice that for each of these, we get different values. We get 30 square inches, 24 square inches, 20 square inches, and that's because all these numbers are different. So as long as the numbers are different, we'll get different values for each of these. That's a good little double check that you do. We'll double this and get 40 square inches for the left and the right. Last thing we need to do is find the total surface area. So we will say the surface area equals the sum of the area from the red rectangles, which is 60, plus the area from the green rectangles, which is 48, plus the area from the blue rectangles, which is 40. What is that? 1640 is 100. So we're going to get 148 square inches. So I'm going to write it like this. All right, done. That's the surface area of that prism. Now, I find that to be the easiest. If we want to use the formula, that's my method too. We can use the formula. Then let's go back and look at that formula. Let's write that down. So here's that formula. Surface area equals 2 times length times width, plus 2 times height times length, plus 2 times height times width. And sometimes these will be in a different order. But what I find is when students use this, they forget which one is which and just start subbing in random numbers, and they make mistakes. So my recommendation, if you're going to use the formula, is you look at your prism, and then you designate which side length is the length. So I'm going to call 6 the length. And no, as long as this is rectangular, it really doesn't matter which one is the length and the width and the height. But I will make the length equal to 6. So I'm going to type that out here. Length equals 6 inches. And then I need to find the width of it. I'll call the width 5 inches. That's this distance right here. So I will write that out. I highly recommend writing out the variable and what it equals to. The last one here is the height, which is 4. Height equals 4 inches. Please write down length, width, height, and then what it equals so that our eyeballs are trained to look right here, and then back to the formula, and then here. And that's all we need to do. So we would say the surface area equals 2 times the length, which is 6, times the width, which is 5. And if you notice, we're doing the same calculation we did right here. Look, 2 times the 6 times the 5. That's really, it's the same. That's where that formula comes from. We get 2 times the height, which is 4, times the length, which is 6. Where have we seen that before? That was down here. 4 times 6, and we have 2 of them. And then lastly, we have 2 times the height, which is 4, and then the width, which is 5. And that is what we had is the blue part of the rectangle down here. And so when you do the surface area this way, you get all of those sums separately. 2 times 6 times 5, well, that's going to be 60. Plus 2 times 4 times 6, that was this sum right here, 48. And then lastly, we get 40 from the other sum. And we just have to make sure we put our units down. So this is going to be a total of 148 square inches. That's using the formula. As I said, make sure you write down what each one of these dimensions are if you're going to use the formula. That was too much talking for me. Now it's time for you to do one. Example 2. Use either method, whatever one you like better. Go ahead and find the surface area of this rectangular prism. And number 2, you go. Pause the video and do number 2. All right, this one's like butter, like a big stick of butter. Here we go, method 1. I separated it into the 3 different rectangles, green, red, and blue, found the areas of each. I got 472 square inches. Don't forget your units. Showed all the work for each one of those. That's fantastic. And if you want to use the formula, look at this, method 2. You have to identify each of your variables here. You need to name which is the length, the width, and the height, and then you can plug it all in, and guess what? 472. Ask your teacher which way you should do it. Maybe they won't care. I don't care. Do they care? They might care. If they care, you got to pick the method they want you to use. On to cylinders. Whew, that is fantastic. We're missing part of our top there. Cylinder. A cylinder is basically a can of soup. We're talking about a can of soup here. Okay, a 3-dimensional figure with 2 identical circles. So we have 2 circles, and we wrap around those circles. That's the middle part there. They're connected by a curved edge. Now, Here's the thing. If we were to cut the cans off, I'm going to call it the top and the bottom of this soup can. We cut the tops off. They look like circles. I think most kids can do that. But then you're going to have this tube. And if you cut down the middle of that tube and you straighten it out, then what shape do you get? And that's right, that is a rectangle. Now, we just have to figure out, if we want to find the surface area of a cylinder here, the surface area, we need to figure out some things. First off, what is the area of the end of it right here? That would be this circle, right? If I were to cut that off and put it right here, that would be this circle. How do you find the area of a circle? Well, we already know that. That is pi r squared. We did that earlier in the lesson. And we have two of them, right? Two of them. We have this one as well. They would be congruent. So we would have 2 pi r squareds. That represents the area of, I'm going to call it the top of the soup can and the bottom of the soup can. Well, basically the two circles. 2 pi r squareds. Now, the tricky part is finding the area of this rectangle, because we have to know how high it is and how long this way. Well, they have to tell you this distance here, and that's going to be called the height. Okay, so they have to give you that height. But how do we figure out how long it is? Now, if you remember what I said here, is we take the soup can here, and then what if we were to cut the ends off? We'd get this circle and this circle, and then we took some very sharp scissors, and we cut the can down this way, and we unwrapped it. We would get the height of it. Well, what is that distance that goes around? Well, that would be the same as the circumference of the circle. Remember, the circumference goes around the outside of the circle. So if we have a can and we cut it, the distance around that circle would unwrap to exactly this distance right here. If you remember the circumference of a circle, what is circumference? So cherry pie's delicious. Apple pie's out too. All right, so we get cherry pie's delicious. That is the circumference. That actually ends up being part of our formula here. The area of this rectangle would be pi times diameter, that's this side, times whatever the length of the height of the can. They call it the height. So it's h times pi d. Now look at our formula here. The surface area of a cylinder, we have 2 pi r squareds. That's 2 circles. That find the area of each circle. Well, one circle and double it. Plus the rectangle, which is pi times diameter times the height. And that can be rewritten. Most people rewrite it this way. 2 pi r squared plus 2 pi r, because remember, 2 radius is the diameter, times the height. I guess they just like writing the number 2 a lot. And we do like the radius as opposed to diameter. I don't know why. I like radius. Radius is cool. I like diameter too. Here's our example. Find the area of the following cylinder with a radius of 5. So remember, radius is this distance, okay, and a height of 10 centimeters. So what I am going to do, first let's just find the area of each piece here. Let's find the area of the top. So the area of the top circle, so the area of the circle equals pi r squared. We know that. And so if we find pi r squared, that would be pi times, what do we get? 5 squared. So that is 25. You got to do exponents first, remember? So that is 25 times pi. So pi times 25. And we know that we're using 3.14 for pi, right? So if we multiply 3.14 times 25, what does that give us? 78.5. 78.5. And that would be, in this case we have centimeters, so it would be square centimeters. So that would be the area of just one of those circles. 78.5 when we multiply that out, but we're going to double it, and that gives us what? We got to get that calculator back here. When we double 78.5, we do 3.14 times 5 squared. Got to do the squared first. Got it all. 157. So that would represent the area of, I'll say, the 2 circles. Be 157 centimeters squared. Okay, so that's this part. Found the area of that circle and the area of this circle. So now the tricky part. We got to find the area of that rectangle. We'll do that over here. We'll use a different color. So the area of the rectangle. Well, they told us it has a height of 10. So that part's easy. So the area of a rectangle is just length times width. We got the height of 10. I need to know, if I were to unwrap this, what that distance would be around the outside. That is also the circumference. So remember, circumference equals pi times diameter. You got to be careful. They gave us the radius. The diameter would equal 10. Diameter equals 10, right? Because you got to double the radius. Remember, the radius goes halfway, diameter all the way across. So this would all equal 3.14 times the diameter, which is 10. And I know that is 31.4. So when I look at the rectangle that's created from this, it's going to be this rectangle that looks like this. The height of it, they tell us, that's 10 centimeters. And then around the outside, that's the circumference of the circle. That is 31.4 centimeters. So the area of the rectangle would equal 10 times 31.4. And so the area of the rectangle would be, just got to move the decimal, right? 314. We're still talking square centimeters. So the area of our cylinder would be, if we take that rectangle that was created and add to it the area of these two circles, we figure the area of the two circles is 157 square centimeters. We can add those together. We get 471 square centimeters. That is the surface area of our cylinder. Easy enough. Now, if we were to use the formula, we would have to write out the formula, and then we have to define all of our variables. So the radius equals 5 and the height equals 10. Then we have to plug everything in. And so if you notice, for pi, we use 3.14, and the radius is 5. Then we got to square it. And then we have 2 pi r. Oh, I forgot my radius in this formula. Mr. Kelly. So there we go. Went back, put it in there. See, that's why it's important to double check and write them all down. I put it all in the calculator here. Hopefully it gives me the right answer. 471. What did we get over there? 471. Oh, goodness. And make sure we have our units. So the surface area, that is a crazy S, equals 471 square centimeters. All right, now this one's a little trickier, so you have to practice too. So do these two, pause the video, then come back and we'll check them. Pause the video and try them on your own. Just do it. Okay, we are back. And look what I got, 131.88. Here's the way I did number 4. Number 4, I just found the area of each circle and then doubled it and then found the area of the rectangle. So the radius is 3, so 3 squared. Be careful, 3 squared is 9, not 6, times pi. So it's pi r squared. Then I take that and I double it because there are 2 circles. So this is the area of the circles, 56.52. Then I need to find the area of that rectangle. So that's pi times diameter all the way around. The diameter is 6, so be careful. So pi times diameter times the height, that gives me 75.36. Add them together, 131.88. Let me know if I made a mistake in the comments. Now, the formula one. And I saved the putting it in the calculator for last, so I can teach you how to do that. What do we have? 8. So you write down the formula. If you're going to do it this way, that's fine. But you have to write down the formula, and then you write down what the radius and the height are. So I did that. So here we go. The surface area equals 2 pi r squared plus 2 pi r, be careful, the radius is 4, times the height, which is 40 here. So I'm just going to plug this all in, just like we see it. 2 times, and then I'm going to use parentheses, 3.14. Remember, you don't need to put the times button if they're next to each other in math. We have a 4, so I'm going to put that in parentheses, and we have an x squared button here to square it. And then you have to hit to the right. And then 2 plus 2, 3.14 times 4 times 40. And I always put parentheses around my numbers when I plug them in. It's just a good habit, so when you get to algebra, we're all ready to go. And I get 1105.28, but we can't forget our units. So 1105.28. What is our unit here? It is meters, so our surface area unit would be square meters. 1105.28. And that is how you do numbers 4 and 5. It's how you find the surface area of prisms and cylinders. Good luck to you out there. This is a long video. My apologies. That was a long video. Too long. Good luck on your homework. Make sure you're checking your answers. This is Mr. Keller. Remember, it's nice to be important, but it's more important to be nice. See ya.